Hello everyone. In this video, we're going to be simplifying an algebraic expression. We're given that a plus b plus c is equal to 0, and we have to make sure that none of these values are equal to 0. So a, b, and c are all different from 0 so that our expression is well defined. All right, so under those conditions, let's go ahead and try to find the value of a squared over bc plus b squared over ac plus c squared over ab. Now, we've done similar problems before, and this kind of goes along well with a couple other problems, which I'm going to link down below, so you can kind of check these videos out as well. And I'll be presenting two methods. So let's start with the first method. For my first method, I kind of want to start off with a plus b plus c equals 0. And from here, in my second expression, let's call this first expression and let's call this second expression, so I can always refer to them with numbers. In the second expression, I have a squared b squared c squared in the numerator. So I would like to isolate, and I have a bc as well, or ac or ab, but I can't really isolate ab or AC or BC from here. Well, if I multiply both sides by something, I probably could, and that could be a third way to do it, by the way. I haven't really explored, but let me just introduce two ways. Okay, so from here, here's what I want to do. I want to isolate A, write it as negative B minus C, B as negative A minus C, and C as negative A minus B. Those are the ones that I'm going to use here, here, and here. So that's going to be my first method. Let's go ahead and plug those in. Negative b minus c squared, that is divided by bc, and this is negative a minus c squared, that is divided by ac. Easy to follow, right? Negative a minus b squared, and that is divided by ab. Now, notice that inside the parentheses, I have something that is like negated, right? So it's kind of like this is the opposite of b plus c. But when you square it, the negative doesn't play a role. I mean, it just disappears, sort of, right? Negative 1 squared is 1. So I can safely say that this is the same thing as b plus c squared. In other words, this expression is equal to b squared plus c squared plus 2bc. Allow me to write it that way because I'm going to separate it accordingly. And this is a squared plus c squared plus 2ac over ac. And then a squared plus b squared plus 2ab over ab. By the way, it's really warm during the day and the AC is on, which is a different AC, right? Okay, what am I going to do with this? This is the expression I'm trying to evaluate, so I need to simplify this as much as possible. And the only thing I know is this one, or these, right? Okay, so how do I use those? Here's what I'm going to do. A little bit of algebraic hocus pocus. Okay, ready? So I'm going to separate these. This is kind of fun. And when you do, you're going to get something nice, because when you do that, you're going to get 2bc divided by bc, which is 2. So you're going to get the 2 3 times. 2 plus 2 plus 2. Notice that? But let's go ahead and separate these first. B squared plus c squared over bc, a squared plus c squared over ac, and a squared plus b squared over ab. Plus 2 plus 2 plus 2, that is going to be plus 6. I hope that makes sense. Okay. Now, here's what I'm going to do. I'm going to separate this even more. B squared over bc is, let me write it here. B cancels out, is b over c. So this is b over c plus c over b, kind of like reciprocals. A over c plus c over a, and this is a over b plus b over a, and then I have to add 6 at the end. Cool, and we're going to manipulate this a little bit more. How? Well, we can kind of, what am I looking for? This color, okay. We can kind of put two terms together so that we can take advantage of the original expression. But this time, I want to manipulate this a little differently. And here's how I'm going to do it. A plus b plus c is equal to 0. So from here, I can also say a plus b is negative c, a plus c is negative b, and you don't write the a. You don't get the a 3 times. B plus c is equal to negative a. So I can use these now. But the question is how? And here's the answer. If you take b over c and pair it up with a over c, yay, they have the same denominator, so I can add them. Awesome. And when you add these two expressions, you get b plus a, or a plus b over c. So this is what we get from here. A plus B over C, which is what comes from here. And then the rest will just follow. Same pattern, same old, same old. A plus C over B and B plus C over A. So we kind of did something smart. We first we substituted, and then we expanded it, and then we reorganized it. And then we found some numerical values like constants, and then we had to substitute again. So a lot of algebraic manipulation, and I think in the comments somebody was talking about, please talk about algebraic manipulations. I hope this meets that criteria. And this is what we end up with. But guess what? A plus B is the same thing as negative C. Yay! And I have an A plus B here. Isn't that awesome? Yes, so this gives me negative C over C, negative B over B, and negative A over A. Plus 6. Now this is why math is so awesome, because you keep substituting and you get different things. Now negative C over C, as long as C does not equal 0, is equal to negative 1. So this is negative 1 minus 1 plus 6. And that is the same thing as 6 minus 3, which I believe is equal to 3. So the answer should be 3. But let's go ahead and verify that with our second method. Let's see what the second method tells us. We should not be getting a different answer, right? And the second method is kind of cool because, and I don't want to start off with that. The second method is kind of cool because it uses a little bit of factoring, and it's kind of nice. Now we know that A plus B plus C is equal to 0. And also, hopefully, we know that A cubed plus B cubed plus C cubed minus 3ABC can be factored. Where does that come from? You'll see in a little bit, just be patient. Now this is factorable, and it's actually divisible by A plus B plus C, which is really, really cool, and you can verify that. And the other factor is kind of like a sum of squares and then subtract from it the two-way products. So this is a really nice expression, and you can always verify that. Really, really cool formula. So we know A plus B plus C is equal to 0, and what does that imply? It implies that the left-hand side is equal to 0. So A cubed plus B cubed plus C cubed minus 3ABC is equal to 0, which implies A cubed plus B cubed plus C cubed is equal to 3ABC. And you're like, what? So what? Well, here's the thing. What is the original expression? What is the expression, or what is the second expression? Is A squared over BC plus B squared over AC plus C squared over AB. And if you make, yes, this is the coolest part. If you make a common denominator, multiply by A, multiply by B, multiply by C, you get A cubed plus B cubed plus C cubed over ABC. That, since that's addition, I just have to write it once. And we know that A cubed plus B cubed plus C cubed is equal to 3ABC if A plus B plus C is equal to 0. And this gives us 3ABC divided by ABC, which is equal to 3. And this brings us to the end of this video. But thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and hasta la vista.